T equals to 2 pi times the square root of L over G. This is the formula for calculating the period of a pendulum, and based on this formula, there are two factors affecting the period of a pendulum. But first, before I go into that, I'm going to tell you what the meaning of the term period is. The term period in physics simply means the time taken for one complete oscillation. An oscillation is when the pendulum bulb moves back and forth. Now, this is one oscillation, and we can keep counting. This is two, and I think two and a half. Now, back to this equation. What this simply means is that the period of a pendulum is directly proportional to the square root of the length of the strings, and the period of a pendulum is also inversely proportional to the square root of the value of acceleration due to gravity. So from what I've written here, I'm going to tell you the two factors that determine the period of a pendulum. And these are: number one, length of string. From the expression T directly proportional to the square root of L, when there is an increase in the length of the string, this also means that there will be an increase in the period of the pendulum. And likewise, when there is a decrease in the length of the string, there will be a decrease in the period of the pendulum. I'm going to illustrate this using a simple graph. Here, I'm going to label the y-axis as T and the x-axis as root L. I'm starting from the origin point. I'm going to take a line like this. So what this graph means is that when there is an increase in L, let's say L is at this level, T is going to increase to this level, and it keeps going on like that. T here, L here, T here, L here, and it keeps increasing and increasing and increasing and increasing. As the length of the string increases, so does the period of the pendulum also increase. Similarly, if you square both sides of this expression, you have something like this: C squared directly proportional to L. And I can plot the same graph. This time I'll have C squared at the y-axis and L on the x-axis, and basically the graph will still be the same. 2. Acceleration due to gravity. From the expression, the period of a pendulum is inversely proportional to the square root value of acceleration due to gravity. What this simply means is that when there is an increase in gravity, there will be a decrease in the period of the pendulum. And when there is a decrease in gravity, there's going to be an increase in period. So I'm going to now draw a graph to represent this expression. I'm going to label the axis for y, t, and for x with g. So the graph is going to look something like this. This is the relationship between t and g. It can also be written as something like this. But still, the y-axis is t and the x-axis is with g. Oh, pardon. 1 over root g. Where it is 1 over root g is now as if t is directly proportional to 1 over root g. So the graph is going to look something like this. I want you to take note of something which I'm going to illustrate with a video. Gravity on the Earth's surface differs from place to place. There are places on Earth that experience more gravity and places that experience less. For instance, gravity is weaker at the equator but stronger at the poles. The north and south poles experience stronger gravitational pull than the equator. That's it for this video. Please like and subscribe to this channel and share this video with others who might be interested, and feel free to comment if you have any questions, or you can also comment if you have any suggestions on videos I should upload. Thanks for watching.